All right. Hello, everybody. By the way, that offer stands for everyone here, so if you want a free box of food, come see me after. So today, I'm going to be talking about implementing speech recognition in your app. But first, a couple of quick PSAs, just kind of reiterate. Yes, I manage the mobile team at Blue Apron. Our mission over there is to make incredible home cooking accessible to everyone. And our mobile team is doing that in a 100% Swift code base, so that's fun. The other thing, as he briefly mentioned, I do organize the Brooklyn Swift Developers Meetup, so if you live here or if you're here next week, we're doing a meetup there. Just check out the website and definitely come out and say hi. All right, speech recognition. This is it's an interesting topic. There's a lot to go over, so I'm just going to kind of dig into it. Before we get to the implementation details, though, I wanted to just spend some time going over a brief history of speech recognition. So in 1952, Bell Labs built the first speech recognition device. It was initially limited to numbers only. By the late 50s, they were able to get it up to about 10 words or so. So very basic, but making progress. Another limitation was that it was single speaker only, meaning if you trained it, it would only work for you. It's not going to work with anyone else. In the 60s, a group of Soviet researchers created the dynamic time warping algorithm, which made it easier to find similarities at different speaking speeds. So, for example, if I trained it by saying Swift, and then I went back and said Swift, or more appropriately, Swift, it would recognize that those were essentially the same word. Also, with dynamic time warping, we were able to see a pretty decent increase in word count to about 200 or so. In the 70s, DARPA funded the Speech Understanding Research Program, which was a 5-year initiative with the lofty goal of creating a system capable of a 1,000-word vocabulary, which, to put it in regular terms, is essentially the vocabulary of a 3-year-old. A group at Carnegie Mellon actually achieved this in 1976 through the use of beam search. The 80s brought us the 80s brought us lots of things, but one of the things that it brought us was a voice-activated typewriter. IBM created it. It was called Tangora, and it was capable of a 20,000-word vocabulary. We also start seeing the first uses of the hidden Markov model in speech recognition. So we reached a new milestone in the 90s when system vocabularies grew larger than your typical adult. There were actually lots of things that happened in the 90s. Some of the other breakthroughs were continuous speech recognition. So you could have more of a conversational tone with the device versus having to pause after every single word. Speaker independence was another big breakthrough, meaning if one person, again, like if one person trained it, anyone else could use it, albeit with some, very minimum voice onboarding. So, and this last one is what really kind of opened the floodgates for commercially viable speech recognition products, with a company called Dragon leading the way with its naturally speaking program, which you may remember. In the early 2000s, speech recognition was hovering around 80% accuracy, which sounds high until you think about having to autocorrect 1 out of every 5 words, which not so great when you put it that way. This is the first introduction of long short-term memory, or LSTM, which is the first deep learning method actually applied to speech recognition. And by 2007, LSTM was outperforming all of the traditional methods. So this, coupled with, in 2007 was also a banner year because the advent of smartphones and everything really helped bring additional commercial products available. So like Google Voice Search and, of course, later Siri were able to acquire massive amounts of data in order to train their models. To the point where today accuracy rates are closer to the mid-90s. So, fast forward to WWDC this year. Apple finally opens up Siri to third-party developers, and this is something that we've wanted for a number of years. So, in order to kind of realize what the potential impact for something like this is, let's pretend that you work for the hot new startup WeezerPay, which allows you to send and receive payments with the band members of Weezer. It is a niche market, but highly underserved. So you can imagine if you added SiriKit support, you could say something like this. Hey Siri, send Rivers Cuomo $5 on WeezerPay for recording the Blue album. So SiriKit will then deconstruct that. Yes, I know. I mean, it's called Say It Ain't So. I had to make a Weezer reference somewhere. So the domain, it can determine that the domain is payments. The intent is to actually send a payment. And then from there, it can actually figure out that the app you want to use is WeezerPay. And then it digs into more payment-specific things like the actual payee, the amount you want to send, and even the reason why you want to send it. So this is great, except they got to the slide where they list the supported domains coming out of the gate. So, I mean, if you work for Slack or Uber or even WeezerPay, this is really excellent news, but for everyone else, not so much. So it's kind of a bummer, but all is not lost. There was another session at WWDC where they introduced a collection of speech APIs. So now I'm feeling a little bit more like this guy. By the way, this was from 2014 when they introduced Swift, and I've been waiting 2 years to use this GIF. All right, so let's talk about the speech framework. It's the same speech tech that's used in Siri. You can use a live audio from a live stream from your microphone or pull in a pre-recorded file from disk. Not only does it return the recommended transcription, but it also returns an array of alternative transcriptions as well as their associated confidence values. And it supports over 50 languages and dialects. All right, so let's dig in. Beginning in iOS 10, you are required to explain why you need access to other services like location and push notifications. So for us, we need access to two services, speech recognition as well as mic access. So you need to make sure that you add both NS speech recognition usage description and NS microphone usage description to your info-P list. Next step, import speech. This is where you get all the fun APIs. The speech recognizer allows you to define the context of the query by setting the locale. So you can set a specific language, like US English, or you could even use the user's current locale. And if you're wondering whether or not the speech APIs will actually support these different locales, you're probably covered. We're talking 58 total locales, which I did a cursory look at what the commercial speech recognition SDKs provide. And this is, from the ones that I saw that people were referencing a lot, this is more than all of them. And this is great because it allows you to connect with your users in their language. So when a user initiates their first request, this is the appropriate time to prompt for access to both speech recognition and your microphone. Make sure you request this at the right time. App launch probably isn't the right time to do it. So when they push a mic button or they're ready to speak, that's probably when you want to do that. All right, so we're authorized. Let's go ahead and walk through constructing a live speech-to-text query. The recognition request defines your audio source. So again, like live versus pre-recorded. You're going to want to use SF speech audio buffer recognition request if you're doing a live stream. If you want to reference a file on disk, you're going to use SF speech URL recognition request. And then I also just wanted to call out the last line. You want to make sure to set should report partial results to true if you want to display the query during processing. So if the user's saying a long sentence, you want to get and you want to show feedback immediately, you want to set this to true. Our recognition task handles the result of your recognition request. So we can see here, this is where we're going to actually display the results back to the user. I also wanted to mention here that you can look towards the bottom. Apple does set a 60-second limit to any individual speech request. So if you happen to reach that threshold, it's going to return as final, as true. Use AV audio session to initialize your audio. And this is something that you're only going to want to do when you're ready for input, because it's going to interrupt most of the audio streams on the device. And I say most because there are certain ones that have a higher priority, like making a phone call. The AV audio engine manages the state of your audio stream. So this is where you define your output format, you install your audio tap, and you basically kick off the whole thing. So if you want to start when you're finally ready to go and everything is initialized, you're going to call audioengine.start. So we're about to see a live demo of speech recognition in action, hopefully. We'll see if it actually works. But before I do, I briefly wanted to mention SF Speech Recognizer Delegate. As you can see, it's very, very small. There's only one method to use, which is speech recognizer availability did change. So this is effectively like an internet reachability for speech. So if you're handling, you're processing a request, and for some reason you go offline, the server stops responding, you'll get a change in your availability, and then you can respond appropriately. All right. It's demo time. Here we go. All right. So I have a very simple demo app I made for this. It's called Say What. It's a very, very basic app that connects to the Spotify API and allows you to do an artist search. So let's say I search for Swift. You can do it through text if you want, if you're old school. And of course, Taylor Swift is the first result. And apparently there actually is a band called Swift. So that's good to know. But enough of this keyboard craziness. Let's actually use some speech recognition. Weezer. There we go. It worked. All right. Great. Okay, so quickly, some gotchas. Make sure you set the permission, your correct permissions in your info-p list. You need to, again, explain why you need access to these services. If you don't do this, your app is going to crash. There are usage limits, both on a per-device and a per-app basis. Unfortunately, these aren't published by Apple. So if you're anticipating lots of usage for your particular use case, then you might want to reach out to them. And again, just wanted to reiterate, you have up to 60 seconds of live audio. All right, so this brings us to UX considerations. Choose your context wisely. Think about the scenarios where it actually makes sense to use speech recognition. Text search, like we just saw, probably makes some sense. Anywhere you're going to be doing short dictation, like a to-do list, might make sense. If you're making an app to dictate your novel, I mean, if it's a really short novel, I guess, sure. So Your user's sense of security is incredibly important. If you break their trust, it's going to be very hard to gain it back. As such, you always want to alert the user when you're recording their voice. Additionally, if you, kind of going back to the max threshold, if you think that people will be hitting that a lot, it might make sense to alert them when they're approaching that threshold instead of just cutting it off right then, because then they think the app just stopped working. Finally, international language support. So instead of defaulting to English, this is your chance to allow users to speak using a language that they're comfortable with. And that's something that's going to improve the overall experience for everyone. Two caveats to that, though. If you haven't translated your app, like fully translated your app over to other native languages, you're going to want to message somewhere in your app that you actually do support native language speech recognition. And the second one is if you are hitting endpoints or third-party APIs or private APIs, you need to obviously make sure that those endpoints will support native languages as well. So for references, I definitely recommend watching the speech recognition video from WWDC. It's 12 minutes, it's very short. Henry Mason was the engineer that did it. I pulled a lot of my information from there. And then the sample app that I just showed is up on GitHub. You feel free to play around with it. You should be able to find me on GitHub. Just search for Marc Brown. It should be easy. And that's it. Thank you.